Hello guys, my name is Amit. Thanks for joining me. I'm going to talk about Black-Scholes model, options, Greeks, and option price methodologies in Python. So in this video, we are diving into a fascinating world of option pricing using the Black-Scholes formula, Black-Scholes model. We will break down take Greeks like a delta, gamma, and vega. I'm gonna show you how to calculate it and some example in Python. But first of all, we need to understand very well all parameters, all mathematical formulas, and how they are working each other, and why we need to know about Black-Scholes-Morton model. So Black-Scholes-Morton model, some assumptions. I want to give you some assumptions. Uh, I want to give you some parameters and explanations, but this video won't be so long. And actually, there are a lot of assumptions, but what's important assumption you should know, and I want to give before starting coding. And first of all, log normal distribution. You have to know because asset price follows log normal distribution. What does that mean? Underlining asset price follow log normal distribution. Next slide or next page, I'll give you some contents return on normal distributed formulas and differences between them. But you should know log normal distribution and normal distribution, what is their differences and understand them deeply. I can give you every step on every page and every formula's explanations that I don't have more time about it. This is really so hard to understand. There are a lot of big knots. Respirate okay, respirate is can't unknown. That means you know every market has different respiratory rate, optical rate, however you want to call. And sigma, I mean volatility is constant. And now, actually, this part is so hard, and I think this part is so hard more than virtuals. Because volatility is really understand very well before starting the lectures. Market model volatility is everything, and there are different which sigma methods, DSM. These are econometric methods and stochastic guys. So you are risk manager or you are working in risk area. Econometric methods is not for you, but it that's rather options quantitative analysis. You should really understand very well the practical methodology. Next week or next time, I'll try and give you some explanations how they are different working and economic model has some example like arbitrage methodologies in statistics as plastic methods have different growing margin those lemma the process. This is so hard really, but you can really handle it together. And markets are fractionalists, guys. This is really important. Try to understand how well, I mean, my work in this video market are fractionalists and underlying asset. Asset has no, has no cash flow, no dividend rights, no dividends. Another one is options are European, not not American. Of course, we will have American options. But now you should understand with European options, all example and intellectual mountain. Then another assumption is log normal stock prices stuff. Log normal, log normal stock prices. What does that mean? This is our log normal stock prices formula and that's both time and normal I can't remember it. And then spot plus mu. This is mu. Right. Mean in statistics. Over 2 and sigma. Okay. This is our volatility in sigma square and This is not normal stock prices, guys. Always remember, log normal stock prices. Okay. If stock prices look normal distributed and then their differentials different are normally distributed. Understand very well it. Like if stock price is equal of normal, like normally, then their return normally distributed. Right, I'm so sorry. My writing is very bad. I know. This time I will handle it. And then Black-Scholes model. Yes, Black-Scholes model. Time is model called Black-Scholes model, and we have yes, Paul, yes, Paul, and wait, this formula. We have Black-Scholes model call and Black-Scholes model good formulas. Two different pricing formula. All formulas is pot, that mean pot stock price, cumulative normal E1 minus strike over RT, wait, P minus RT times N P2. This is PV, present value of strike raw. Remember it always. Always remember it. You should memorize it. This is PV strike. Another one, P1 is the intellectual formula, but you will have some probability from cumulative normal distribution, and we will use it here, okay? P1 and P2. P1 formula is ln of over strike plus risk, risk plus the percentage 0.5 times sigma square, okay, times t. Maybe you can see this here like yes, the same row. And over sigma times t, root here. You will understand everything. What does their formula mean? Why we need to have and P1 minus sigma t. This is done like a standard Boolean, so like a variance, you know. You should do understand, right? And this is our Black-Scholes formula, and you should understand it very well. This is our probability, and this is our spot price, this is our strike price, okay? Strike, first value of strike. We have some parameter like T is time to maturity, Oh, no. Maturity, like, as percentage of 365 day year. We have 65-day year, and S0 is asset price, stock price, same, and strike is exercise price. We are betting asset price will move or down or up, exercise price, and R is continuously grow. Remember here, always remember here. We have clear rate, but it should be on continuously compounded, like the effective rate. We have effective rate, you will learn over minus RT, like the effective rate with clear rates. And sigma is volatility of underlying stock return. Okay, stock returns, not stock price. Someone is understanding that volatility of stock prices. No, never stock prices. Stock returns. And and B is normal probability. Always remember this. And maybe I can give you more detailed information about this. Maybe you can't remember this formula, but always remember the option value. Calculate option value, right? Option value is equal to price times probability, right? We are doing it. Yes, so price times probability. I know all statistic is based on this formula. Bias or another one is stock price is probably to mean that S1 was S0 on E1. Okay, then yes, okay. My headphones broke it all. Probability PV of exercise PV of exercise price times sorry of exercise price times probability of exercise. That's mean and the two and like L over RP. So look, this is same. These are spot and auction market stock price and times probability. It's the same, bro. Always remember this. Maybe you can't remember it, can't memorize. You know, it is really hard to understand and memorize. You should know this. Surprise or probability minus exercise. I mean PV of exercise time probability. So I can give you some example about this. I can calculate intellectual smart model. Like maybe it's not so scary, but it's really easy to implementation. Example here, vanilla. You know, vanilla is option tag. Vanilla is trading fee, and RF pays 5%. This is continuously, rather continuous compounded and analyze its conduct region is 30%. And this is random values. And the call, you know, just remember call and value 3 months call with $45 and saving $50. No, option calculate, right? Calculates. And then this is the and 0.5 cal 3 minus 3 hour 12 is 0.5. We have 12 months in a year. And then let's implement formula. E1 Q ln P over strike 45 plus 0.5 times 0.3. This is sigma, over square times 0.5. This is T. Then 5 times 2, and it should be equal, like, let's calculate it. Then, you know, this is 0.5, and this is 0.0135, and then the square of this should be 5 times 3, and then this is equal plus, and then this is equal 0.56. Another one is the Q. We have 0.86 main is probability 30 minus 0.5 kill or 0. These are all probabilities. Okay, these are all probable. What does it mean? These are all probable, and we have to check out the normal distribution. We should find all these stars. So let me normal table. Okay, this is negative, and the value, and then it's positive the value table. Now you should decide. We have to understand negative and positive sides in this part. What are the ratios? 0.65 is one. One is A1 is kill. All these scores. We find our probability and check it normal distribution. That's normal distributions. The standard non-linear non-distributing tables. We check it our probability and we find it 0.1 digits. Okay. This is fine. Okay. And now all that's left to plug into Black-Scholes whole formula. Okay. This is Black-Scholes whole formula here. Now let's plug it. It is all zero strike times our probability and bombs. Sorry guys. My bad. My bad. 0 1 minus right Taylor with 35 50 times return 0.5 0.2. Okay, times here another probability guys. Always remember here. Always remember here, okay? X1 and D1 plus probability. Always remember here. And then if we calculate uh 50 times 0.8 so times times 2 and 33.8. So here writes yes 6.4. So that's mean the call is today. Okay, verb is today. And that is very comparable to using good call parity with continuous compounding. What does that mean? Call parity. And we have call parity. So comparable groups call class strike T brilliant strike and equal B plus S K. That's mean we know call price here and then plus strike ERG. Sorry, no need to write again. Wait. My bad, guys. Taylor, sorry, over 5 times 5. So we need to find it, how we can find it is because parity is so important in options. We can find it with arbitrary pricing methodologies. This is a fundamental relationship in options pricing that links prices of European pulp proportion with sales strike and expiration dates. Change strike and safety. Okay. European pulp proportion with change strike and same relationship. We have this equilibrium here with parity call plus the value of strike. This equation implies that holding a long call and short put with same strike and X price is equivalent to holding a forward contract on underlying asset. In other words, call minus put equal in static forward. That's static forward. In this relationship, does not hold an arbitrary. Uh, I mean, if this relationship does not hold, maybe this is high or this is low. Maybe they are not big deal. That's mean an arbitrage opportunities of sense. For example, let me explain. So if all plus p story minus root bigger than spot minus strike p are so-called I put if this equation so-put so-called by it reverse by call to put This is arbitrary tail options. But you know, if you are looking arbitrary, no transaction cost, and the European options and no dividends. Okay, remember it. No dividend, never dividend. Always remember it. And in it is when another relationship all and food and how they affect both and right parameters. If like imagine this cash flow, cash flow on underlying asset affect option value. How they affect option value, decrease or increase, reducing call and increasing put value, right? If spot reduce minus strike, call affect negative. Strike minus spot reduce put is affect positive. Maybe I can give you a chart of the affect parameters all and put values. But you should have to know spot is affect negative call, but strike is affect negative or positive because they have health. You can look health and understand everything. They have an health. This is whole health. This is good health. Okay. Strike affect positive food, but strike affect negative call. And if we have risk-free risk-free rate are called positive. Blah blah blah. This video had a really long time. I remember everything and I want to talk about everything. Next one is I want to talk about its warrants parts. Okay, warrants. Warrants really simple to understand. They have like options structure, but not option. Warrants are attachment to bonds issue which give the holders like um, purchase share of a security's fixed price. There, so that's it. Like for example, in my tablet, in warrants work. Yes, warrants, warrants warrant has fixed price. After purchasing the bond, warrants can be exercised separately or stripped from the bond and sold to other investors. This advantage of warrants, they can be valued as a separate call options on the firm shares. And then, unlike call options, when investors exercise warrants, investor purchase shares directly from the firm. Maybe this is the disadvantage of the warrants. Maybe this is disadvantage of warrants. By being ways and warrants have some formula, some parameter, for instance, and over and plus. What does it mean? And is number of shares outstanding. Okay, outstanding. And is number of new warrants issued. And uh, additionally, the total cost of issuing warrants is um sometimes the value of each warrant. I'm speaking really randomly. Sorry me. Maybe I have some bad, wrong. Forgive me. I have to give you an example again. Spot is stock price and chill 1 million is 2000 call is and W. We could find W. Okay. W is here. W is here. So it's going to show We have regular call-ups in here, number of times, and here call. Okay, regular call. Regular call. And we chill $7 times 1 divided by uh, 1 million plus 200 is equal of 1 million. No, still 5.89. Okay, 5.89. That's sorry, it's 3.83. So we should find total cost and our share. Total cost over share. What is our share? This is our share. And what is our cost? One cost is 5.83 times 2k plus and is 200k over scale 1 and this is 0.5k. This is changing delta. These are enough for warrants. These are really enough for warrants. You should only understand what is warrant, how they are working, why they we need to have it, and warrants are bond issues which you hold the right first price scales of security stated price. However, unlike call option, I repeat again its same words. When investor exercise warrants, investor third price shares directly from the fund. It's a basic. And another chapter is, I think, volatility and volatility estimation. It's really important. There are really a lot of parts say about this chapter, but I'm going to give you briefly implied volatility. Okay, implied volatility. Implied volatility is the return on underlying stock is sigma from yes model that makes model value equal market price. All right, the market price, and this is implied volatility and historical volatility. This is easy because it's the standard STD of continuously only here is import continuously compounded returns on stock depends on stock and implied volatility. Maybe I can give you an example about implied volatility. We don't suppose market price and really bad start. Next time I improve my writing. Market price 3 month 45 again 111 call is 7.1. We had different volatility input and we had different value from Black-Scholes inputs and value from yes like 5 30 35 40 45 and this is our ESM values. Now it should be increase 0.7 and and we are confident here last seconds instruction this right. Okay, last column I'm in values 7.17 and 7.59. So that's mean it's like in like wow is 40% and 25%. It's really not easy to explain by the looking example of the purposes and logic, but this is enough for finally understanding the applied volatility mentioned. Then Black-Scholes Merton. Maybe I can give you again an example, but we don't have to need it. But we already calculated and PV actual spot strike. I'm checking what I talk more call nice puts that synthetic CSM. Okay, Black-Scholes call example. Last time. Black-Scholes call example. If we have 0 is hundreds and exercise price is risk is 3, time to maturity is 1 year, and ND1 is 0.64 and D2 is 0.56. We need to implement all numbers on the DSM call formula. Okay. So this is spot. Okay. So it's strike times RT. It's the strike price value. I already mentioned it. At the time one minus or minus probability. Now minus 2 0.65 times T. Oh, okay, brother. Calculate it on take yourself. It's easy. But always remember that keyword is most important point is always know how can you find these probabilities here. Okay? Out your table. You should know how can you all probabilities in the table. Start the probability in your time we are computed probabilities with spot prices. This is in cost batch. And another one is let's exercise in time. How can we calculate it? It's so easy, brother. It's so easy to implement. I won't give you more information about because already we do have really have a long time. Think of math. Yeah, think of math and have a library if you don't have. From start. Import norm. This is normal cumulative table, And another one again has two equals of hundreds. This is Scott Rice. Keg is equals try again same b to 1 and r equals 0.05 big my equals 0. No, 3. This is what you guys. Oh, I never did it before. Anyway, calculate D1 and equal to what? D1 and D2 keyword. D1 is look. Oh, math. Math plus log move is a lamp. Okay. Minus guy. No, you didn't do it before. How about now? Okay. Plus R minus 0.5. This is our square. I mean, root formulas. And this is B1 formula. Okay, and then we have B2. So sigma too much straight your B, Since saying if you know mathematical formulas, should understand easily. And we have to calculate on D1 and D2. And D1 will norm the absolute normal distribution D1. Yeah. And two is a field with normal distribution of zone D2. So we are used to have BSM all Scott times and D1. How we know it? How we know it? We know. Still, I mentioned it about it. Called Parity and BSM call, okay. BSM call normal distribution keywords right and this space, okay, optimally probable people are minus strike exercise. BSM call and D1 minus K mod X. These are good three formulas. Mod X this mean error mod point X error over minus RT and DT. No. Okay. BSM and then minus XL and BSM with all mod X the same formulas. It's the BSM. They are already calculated. Okay, if I'm taking BSM call, we should find this is our BSM call price. This is our call price. And this is food price. If you want to write it, you can use the grills. Lens F ESM call as call price ESM call as ESM call. Okay, like this, but this is not necessary. ESM call. This is ESM call, and if we have strike 100, sorry, spot 100 and strike this screen 5%, blah blah blah. Are there anything I can say? That's all, guys. Thanks for watching me. Next time, I'll give you some examples about Greeks and in Python exercise, binomial distributions. It is really big chapter in ocean pricing methodologies. Thanks for watching me again. Next time, see you.